Hello, I'm Ryan McEachern, and welcome to The DIG. On this episode, we will be talking to Justin Downey from RWDI about a portable lab that can detect COVID-19 in 90 minutes. But first, we have our own Stephanie Alvarez to share some important information with us. Hi, Steph.
Hi, Ryan. I'm super excited to listen to your interview with Justin from RWDI. On July 7th, MSTA Canada hosted virtual B2B meetings between mining giant ArcelorMittal and Canadian mining suppliers, all of them leading to continued talks and potential new business opportunities. Just one of the many benefits of being members with MSTA Canada.
Thanks, Steph. Sounds great. We'll catch up with you later in the show. RWDI has a portable lab that can detect COVID-19 within 90 minutes. Could this be a game changer in helping control the spread of the virus in the workplace? Let's dig in with Justin Downey from RWDI. Hi, Justin. Welcome to The DIG.
Hi, Ryan. Thanks very much for having me. Appreciate it.
Yeah. Some of our viewers might notice that we have a subtly different background, but there's a story behind that, which if they're interested, they can come contact me. But anyways, thanks again for being on the show. And tell us a little bit about this portable lab that you have that tests COVID-19 in within 90 minutes you get results.
Yeah. Well, thanks very much for the question, and happy to speak about the portable units. But maybe before we get into some of the details on the portable units, I would just give a little bit of an introduction. Clearly, our industry, our world is suffering a compromise in trust of our spaces and places, and there's an immediate need to safeguard our places, our facilities, our spaces, the way that we interact with one another to try and get to a place of safety now and in the future. We see DNA testing and the ability to identify pathogen in spaces and in people as a critical part in that step. There are a few different ways to go about doing that, including the portable Kleenex box-sized kit that you're referring to. That's a portable PCR machine. But that's not the only trick in the bag. There's also custom development, sort of lab in a van deployments, as well as testing via logistical methods with established labs. But the little box that you're referring to go a little bit into that is really a unit that enables us to go out and collect swabs of information and then plug that back into the machine. The machine runs a series of DNA marker identification checks on that, and then tests it against established DNA sequences that we have up in the cloud, and returns hits. So we can identify from a very large library what pathogens we might find in a space or a place. And that includes COVID-19.
And so you mentioned this acronym PCR. Could you tell us what that is?
Sure. PCR stands for Polymerase Chain Reaction, and it is a classification of testing approach and apparatus, and it is the technology that allows us to break down a sample and identify the DNA that is found in it. So these little boxes, or in a much larger scale lab development, this is a common approach to identify a DNA sequence and a pathogen that might be present.
Okay, and you mentioned taking samples. So we're testing surfaces, if I understand what you mean by that.
Yeah, well, we're testing surfaces, and we can also test individuals, humans, people in a workspace or what have you. There is some nuance to that. Certain approaches to testing should be followed. Certainly, you would want a healthcare professional actually conducting the personnel swabs. But in any event, in all of these scenarios, what we're doing is collecting physical sample with a swab using a test kit and bringing it either to a B-Cube machine or we're bringing it to a lab that has been deployed to site, or we're bringing it to a lab that is accessible. And that's where the DNA sequencing takes place. The process involves test kits that are delivered to site under any of those service configurations, and then the swabbing is actually done by individuals involved in the facility, be that sort of on the healthcare side or more on the facilities and maintenance side.
Okay, and that answers kind of a question I was going to ask: is who would do the sampling? You know, is there, how much training is really required to get up to speed?
Yeah, for the surface testing, the training is actually really straightforward, and one of the things we're doing is investing in the understanding of the space and the place, and defining what a test program might be, the frequency of testing, what surfaces should be tested, and working through an education program around a plan that we would help establish. But then really it's about an hour to figure out how to use the portable versions of the machine, or maybe a little more complicated for some of the custom built lab applications and the human side, but relatively straightforward, and certainly something that we can work to establish with a team rather than it being an ongoing presence of our group.
Right, and I think a real key piece to this, you know, we've seen certain solutions of screening for, and we're seeing it from a mining perspective, but yeah. This is an asymptomatic approach. You don't need to have the signs. Someone could have COVID-19 and you could still detect it.
Yeah, absolutely. So there is a role for all sorts of different screening and solutions and so on. And I think that the critical part is that the best line of sight we have right now into the presence of pathogen is via DNA identification. And so that means working through PCR-based machines or otherwise lab to identify DNA. You're right that we're learning a lot about the virus and the transmission and how to respond, and asymptomatic individuals are clearly a challenge to different types of screening methods. So we really think that the DNA portion is critical to getting good visibility to what's actually going on, including whether or not solutions that are being deployed now are truly being effective. Right.
So let's put it in the context of mining. Could you kind of walk through how we see this system work within, say, at a mine site?
Yeah, we absolutely understand mines are unique places. They're unique in the way that you get to them. They can be near, they can be remote, they may or may not have community access, the degree of isolation can vary. Certainly there's logistics involved in rotation, 7, 14, 21, 28 days, etc. There is no single solution. I think a prudent approach would be to be thinking about the perimeter that you establish outside of the site, and trying to develop plans and procedures, including identification of that point of entry of a pathogen, as well as the measures that you actually have in place at the site, both of which benefit from a line of sight, as we describe it, to the actual pathogen's presence in the space or place or people.
Right. So, you know, I'm thinking, at a mine site, it's going to be those places where there's multiple points of contact, be it the camp environment where they're sleeping, be it it could be the gym, rec hall,
absolutely,
kitchens, all that. And you can, could you even look at, say, actually in the underground or in the cage, if you will, on the way down? Is that, and I guess it's in surface.
Yeah, points of vulnerability. I mean, we have, and it's not just mining, our world is built around a fundamental understanding of or assumption about density of people in space and in time. And COVID is frankly challenging that. We can apply this logic, the access to information, line of sight, as well as the solutions, understanding that we have a need to identify those places that are particularly vulnerable. You've named a few. High-touch surfaces are a really important part. Places where you expect prolonged presence at a certain density of individuals, where you have air mixing in a room, or perhaps underventilated in a room. That can be on the surface, and that can be, in a bunkhouse or a cafeteria or so on, or it can be underground. Absolutely.
Right. Interesting. So I'm picturing this. We've taken our sample, we've done the analysis. I think it's amazing that you've got this solution down to the size of a Kleenex box. But what do? We get this positive. It's 90 minutes, which is an amazing time frame. You get this response back, and we have COVID-19. What do we do with that?
Yeah. There really needs to be a deep consideration of the way that you would triage an approach to that. And you will have different levels of vulnerability depending on where you might identify a pathogen. If you were to identify a pathogen in a high vulnerability area, i.e. high density, high throughput of individuals or high touch surfaces, I mean, that is an emergency response kind of scenario. The space needs to be evacuated. You need to be able to identify individuals who may have been contaminated and isolate them. You need to go into deep cleaning and leverage tools around industrial hygiene and so forth. In other circumstances, you might identify a pathogen, but not, maybe it's a surface and it's not in an area that is regularly trafficked, but you use that as part of a track and trace approach. And perhaps your immediate response could be a little less drastic than some. Certainly the cleaning will apply. In the event that you had a persistent identification of pathogen, I think it means that you need to start thinking of some more systemic potential contributors. It might be the way that air moves in a space. It might be the application of filtration for air in a space or surfaces. We might think about changing up the distancing allowances or filtration and so on. So one of the things that we're trying to bring to our clientele is an appreciation for the complexity here, an understanding of the way that you've got a convergence of say the genomic science and the ability to do the DNA testing, plus facility sciences, plus building sciences and physics and air movement, and bring those things together in order to really get a handle on both the challenge and the potential solutions, including their effectiveness in the field.
Right. And what I find interesting too about this is, again, the size, the portability of this solution, the rapid response rate from the testing to the answer, and it as you mentioned, this PCR it can do any pathogen. So this is something that could be embedded into a company's protocol, just as if companies testing for alcohol to get access to a site. It could be just part of the regimen for everything, Ebola, all these Zika, all these things.
Yeah, two points that I would contribute on that, and I think it's well put. One, the distributed nature of this is a game changer. The ability to go to that scale and to get it out to the places, the points of care that it needs to be. Number two, the timing is very important. There are significant challenges to waiting on a sample collected and sent to a lab and brought back. That is exaggerated, of course, in the remote mining area. It is important to have timely information here, and 90 minutes is the current best available technology. We expect that to come down in the future, so it's an area of active development in the scientific community. We would adopt any of that and work with our clients to make sure that we have the best available solution. Certainly the scale of it is critical. And I think that's a real game changer, that combination of scale, flexibility, the ability to go to point of care, and the time that is required.
Right. I think, considering what you're bringing to the table here, as you mentioned, I agree, this is a game changer. And I see the mining community really having a hard look at this. My understanding right now is it's not completely integrated into any mining sites, but it is being utilized at food or processing facilities.
Yeah, one that I can speak to a little bit about is from a food manufacturer who, this is a different industry. They're used to having a highly curated environment and having very careful control. For them, the implementation of a program like this was actually really straightforward. They were up and running, in a day. The hour training was no trouble, and it has really restored a sense of confidence and line of sight, as I say, into their space and their place, which is a huge morale boost for them. It also gives them confidence in their product, that they are not in some way a propagator of the challenge, and I think that's been really important for them.
Well, Justin, I really appreciate you taking the time to share this information to us and our audience, and I expect to see this in the mining industry very soon. So again, thank you very much for taking the time to be on the show.
Very good. Thank you for having me.
And thank you for joining us on The Dig. But before we leave, let's bring back Stephanie. Hi, Steph.
Hi, Ryan. We are accepting new members, and when you join, you will receive 2 complimentary market intelligence reports of the countries of your choice. To know more about our membership and all of the benefits, please email us at membership@mstacanada.ca.
Thanks, Stephanie. Until next time, I'm Ryan McEachern. Take care and stay safe.